Okay, so now instead of 1%, let's take a look at 30%.
Okay.
So yeah, 30% of the population has it. And now we have 95% accuracy. Let's see what happens here.
So the 30% who are infected, 95% of those. So it's 28.5%.
All right, so 28.5%.
So test positive.
Okay.
And then of the 70%, 66.5.
It's negative.
Yeah.
So that means
So 4.
3.5.
Yeah, 3.5.
3.5% test positive.
Okay, so these are this is of the total population now. Now there's only 3.5% that test positive.
Yeah.
Okay.
So we could do the true positives to all positives. 20.5 divided by 32. There's about 89% accuracy for the test.
Okay.
89% chance you have it if you test positive.
I think that's what he said in the Twitter thread, right? It said about
90%.
Yeah.
at 30% of the population having it, you were right around 90%. So yeah, 89%. So that's good, right? So
Yeah.
that means if you test positive, there's a 90% chance that you have it.
Certainly better than a 16% chance.
Right. So for rare diseases, you need super accurate tests. What do you think, by the way? He got into this in the Twitter thread a little bit, and we didn't go all the way down. But what do you think would happen if you just tested everybody twice in this situation? If they test positive, you test them again.
That probably would decrease the rate of false positives because we only have 5% chance of a false positive, or 5% chance of the test not being accurate.
What do you think?
Well, I don't know, because like if we go back, I don't remember it exactly, but if we go back to our 10% or 5%, I think it was.
Mm-hmm.
So you have 4.7.
Yeah, it was 4.75% of the population came from both, so it was equal.
So true positives and false positives. But if we test all these again, they're gonna, so the double positives are gonna be the same out of each people, maybe.
Well, these have a 0.95% chance, or 0.95, 95% chance of testing positive again.
Yeah.
So,
and then these have a 5% chance.
These only have a 5% chance of testing positive again. What assumption are you making about that?
Well, people, you're taking people who tested positive twice, like people who didn't test positive, people who tested negative could suddenly test positive again.
Also, that it's just random error that is making them test positive. There's not like an error with the test that maybe these people have some specific antibody that triggers the test, and these people have the antibody that should be triggering the test.
Right. That's the problem with using the same test twice. Is it's not necessarily independent. These aren't random draws from the population. These are people who are already tested positive, and so you don't know. So really, what you need to do is do something that's independent.
So you need two different tests.
Yeah, but why do you think that's hard? Why do you think two different tests are hard?
You don't really know like what else a person who's had this disease could have, because you don't have a large population of people who have had this disease in the world, because it's a very new disease.
Yeah, so you just don't know. So it's what makes it really tricky.
Mm-hmm.
Yeah.
So it's really hard to identify. So cool. So this is a not just an important math lesson, but something that's very relevant to what's going on right now. So, all right, good job, guys.